Hey everyone, welcome to today's explainer. Today we're getting right into the essential machinery blueprint for an effluent treatment plant, but we're focusing specifically on a mini-scale setup. Optimizing a biological and chemical water treatment process for commercial wastewater at this scale actually offers some pretty huge advantages. By the end of this explainer, we're going to map out exactly how accessible and, honestly, how efficient this technology is when you shrink down the footprint.
Okay, let's dive into this. 5,000. That is our magic number today. We're focusing on treating 5 cubic meters, or 5,000 liters, of wastewater per day. It's a highly manageable volume, but the thing is, it requires a very specific, optimized approach to your utility components. You can't just take a massive municipal design and hit the shrink button.
So, what actually defines a mini-scale ETP at a 5 cubic meter per day capacity? Well, at this size, you completely bypass the need for complex, oversized industrial machinery. Instead, we're relying entirely on small capacity, highly specialized gear. While massive industrial plants are out there running these huge 15-horsepower motors, this scale is perfectly tailored for small factories, localized dyeing units, or commercial setups. You're hitting all those required water quality parameters, but without the heavy-duty, roaring machinery.
Here's our blueprint for the breakdown. We'll size up the plant, talk about moving and measuring the water, dive into the aeration system and chemical dosing, handle the sludge, and then finally, put it all together with the budget.
All right, Section 1. Let's size up these tanks and look at the actual physical footprint we're dealing with. What's really interesting here is just how compact these tanks actually are. You start with a screen and equalization tank at around 3,000 to 5,000 liters, just to catch the incoming debris. Then the water spends hours in the aeration tank, which needs to be your biggest one, at 5,000 to 7,000 liters. After that, it moves over to a settling tank of roughly 2,000 to 3,000 liters, and then finally into a 3,000-liter treated water tank. Whatever gets separated out goes into a small 1,000-liter sludge holding tank. Now, here is the absolutely crucial takeaway. For a plant of this size, you do not have to build expensive, underground, reinforced concrete structures. You can literally just use custom, ready-made plastic or PVC tanks, which dramatically simplifies your civil works. Moving on to step 2, let's talk about getting that water moving with our pumps and flow meters. This right here is where the optimization of the mini ETP really shines. To move 5,000 liters of water a day, you don't need a giant industrial pump. You just need a feed or raw water pump, submersible or centrifugal, either works, with a capacity of exactly 1 cubic meter per hour. Since 5,000 liters is just 5 cubic meters, you're only pumping for a few hours a day to move your entire volume. Because of that, your motor power is incredibly low. We're talking 0.5 horsepower or even less. You'll set up 2 of these pumps, one running and one on standby just in case, and to keep track of everything, you slap a single digital or mechanical flow meter on the inlet or outlet to track your volume precisely. Next up, Section 3, the aeration system, which is basically the biological heart of the whole setup. Now, think about the biology for a second. The bacteria in that aeration tank need oxygen to survive and break down the pollutants, right? So how exactly do we efficiently force enough oxygen deep into 7,000 liters of water? We got to build the mechanical lungs for this operation. And the solution is a small capacity ring or roots type blower. It pushes about 10 to 15 cubic meters of air per hour directly into the water. Notice the efficiency here. It only requires a tiny 0.5 to 1 horsepower motor. Just like with our pumps, you want 2 of these, one running, one on standby. Reliable brands like Trendine from Taiwan, for instance, are pretty standard for this because they are absolute workhorses in these utility setups. And this brilliantly illustrates how the whole thing comes together. Because generating the air is only half the battle. Distributing it effectively is where the design matters. The blower generates the pressure and then pushes that air down to 4 to 6 disc-type fine bubble diffusers sitting at the very bottom of the tank. Those diffusers take that air and shear it into thousands of tiny, fine bubbles that rise up through the water column. This ensures the oxygen is completely and evenly distributed, creating perfect synergy so the bacteria can thrive. All right, on to Section 4, chemical dosing. This is where we get into the precision chemistry. To nail this chemical blueprint, we use diaphragm dosing pumps. We choose these because we need extreme accuracy at a ridiculously low flow rate, just 0 to 6 liters per hour. You'll deploy 2 or 3 of these units, attached to small 50 to 100-liter plastic tanks. Inside those tanks are your chemicals. First, you've got coagulants, like alum or lime, to neutralize the pH and start the clumping process.
You only need about 200 grams to 1 kilogram per day. Next, you add a flocculant, like polyelectrolyte, to bind those tiny clumps into much heavier flakes. And for that, you literally only need a microscopic 5 to 20 grams a day. It's precision chemistry scaled down perfectly.
Section 5. Sludge management. Because what gets separated from the water has got to go somewhere.
So those heavy flakes of pollutants eventually settle down to the bottom of the clarifier tank. In massive industrial plants, you'd see these incredibly expensive automated dewatering screw presses handling hundreds of kilos of sludge. But for a 5,000-liter mini ETP, you have two super practical options. Option 1 is a straightforward manual filter press to just squeeze the water out. Option 2 is even simpler, a small sludge drying bed, where the wet sludge literally just dries out in the air. Both methods really highlight how operationally accessible the scale is.
Finally, Section 6. Let's put it all together and talk about the estimated total budget.
Let's break down the total budget, mapped out here in Bangladeshi taka based on current local market data. Your total estimated cost is going to range from about 4.5 to 7.5 lakh taka. The machinery, the blowers, the pumps, the diffusers, that'll run you between 2.5 to 4 lakh. The civil works and tanks will be about 1.5 to 2.5 lakh. And remember, if you opt for those ready-made PVC tanks instead of concrete, you can definitely push that cost right down to the lower end of the spectrum. Finally, consultancy, design, and installation will run roughly 50,000 to 1 lakh.
And speaking of that consultancy portion, a great reminder from established partners like Techno Bangla Creation Limited, for example, is that working with verified engineering consultants is absolutely vital. They're the pros who look at your raw water test reports, check your BOD, COD, and pH levels, and give you the precise engineering designs and pump specs you need. They make sure you get reliable parts, so your water is actually treated effectively and stays under warranty. So we've taken a highly technical process and completely broken it down into a logical, optimized blueprint. From those efficient half-horsepower pumps right through to the ready-made PVC tanks and the precision chemical dosing. An efficient 5,000-liter ETP is a completely practical implementation. So I'll leave you with this thought. With the machinery demystified and mapped out like this, what is stopping you from optimizing your own sustainable infrastructure today? Thanks for hanging out with me on this explainer and keep learning.